So here are the second fundamental theorem calculus formulas from your book on page 295. And they start out pretty straightforward. They almost seem so easy that you don't know why there's a property. We're trying to find the derivative. Well, the derivative of the integral from the a to the x, f of t dt equals f of x. So we plug in x everywhere there's a t. So x squared over x squared plus 1. And that's it. Second one, again, just plug in an x everywhere there's a t. So we have the fourth root of x and secant cubed of x. Straightforward. The main thing is recognizing that you're going from an integer up to a variable expression on all of these. Okay, and then they get a little more complex. If you notice, we're going from a variable to a variable. And so what you have to do is split this up into an integral from the first variable to a number. It doesn't matter what number. And then add to that from that same number to the ending interval. And then just use the properties we've been using. So we'll start out with the one on the right because it's from 2 to x, f of t equals t, f of x. Okay, when we find that, we get x to the third. On the left, we're going from a different order, and so we want to make it match the property. So we want to change this integral and make it from 2 to negative x of t cubed dt. To switch the order around, we have to put a negative out front here. So when I plug in, I know I have my x cubed. When I plug in here, I'm going to plug in negative x for t. So that's negative t to the third. But since this has a derivative of negative 1, I got to put a negative 1 with it, which makes this positive. But there's a negative out front, which makes it negative again. So, sorry, it shouldn't have been negative t cubed, it should have been negative x cubed. So we went negative x to the third, which is negative x cubed, times negative 1, which made it positive x cubed, and then a minus out front. So we have x cubed minus x cubed, which is 0. The last one, 0 to x squared. All I have to do is substitute. Everywhere there's a theta, I'm going to put in x squared. So I have x squared squared times the integral of x squared, which is 2x. This is one where the derivative of x squared, which is 2x. This is one where the derivative is not equal to 1. So 2x times the sine of x to the fourth, or if you want to leave it squared, that's fine. Last one, plug in. So I have x squared to the third, which would be x to the sixth, but then I need to multiply by the derivative because, again, this is not a derivative of 1. So that's our shortcut. You end up with 2 over x to the fifth.